Welcome back to my series where I am learning how to program in Rust. I went today to try and build something that I would normally build in Java and try and see if I could do it in Rust. I was trying to see if I could do something with the strategy pattern because I'm not really sure how those object-oriented patterns translate into Rust. And so I thought I'd play with one. So the premise is that I'm building a game where aliens and humans fight it with each other. And aliens have this special skill that some of them can recover some of their life points every tick of the game. But not all the aliens recover the same way. Some of them heal all the way to perfectly healed. Some of them don't recover at all. And some recover a percentage of what they're lost. If I was building this in Java, I would use the strategy pattern. Every alien would be given an object that knows how to do the calculation. And when it wants to recover, it would delegate that calculation to the strategy object that it had been given. So I went looking for the strategy pattern, and I got this example, and it's based on traits, which is kind of what I was expecting because traits feel sort of like interfaces to me. And here they have a navigator that can be given two different strategies for how to calculate a route, and they all implement route strategy. So essentially there's a struct for each one of the concrete behaviors, and then you can pass that into the concrete behavior or into the context, into the object that is doing it. So here, when it creates a navigator, this one gets a walking strategy. So the object that it's given is, the struct that it's given is one of these, where this makes a navigator where the struct it's given is one of these. That's exactly the strategy pattern. And I could have built it that way. But my calculate recovery is a really small thing, like, it's like a little piece of math. And so this feels like a lot of overhead for a little piece of math. And so I had read a little bit about closures in Rust, and I thought maybe I could implement this idea with a closure instead, so that the struct for an alien would contain that little piece of code and we could execute it. So I went looking for how do I store a closure in a struct. And I found this great page, which I will link in the description. There's an unboxed closure and a boxed trait object and a trait object reference and a function pointer. And at this point, I have to admit, I looked at these and I was like, I don't know what this where thing is doing. So I need to go learn about that to understand the unboxed closure. This one I can understand, but this is a box of a dynamic function mapping something to something. And then down here, this syntax of foo new some code dot foo 42, this just does not compute. And I totally get, I'm learning a new language. I should embrace the things in the new language and figure them out. But this feels like it is more complicated than it needs to be. So I will admit, I knew what a function pointer was. And when I looked at this code, I could see how this code worked. So my first strategy was to build the function pointer. So I have an alien that's a struct, and it has its current life points, and then it also has its initial life points. And then it has a function pointer that is a recovery behavior. And you pass into that function a mutable alien. So that's self, we can call it on ourselves. And it gives back an integer, which is what the life points should be when we're finished. So in my implementation of alien, I have a constructor that is given an initial life points and a recovery behavior. And you can see I'm passing in a function that matches that signature that in the recovery behavior description. Then I made little functions for each one of the possible calculations. So you could recover a percent, you could recover all, you could recover none. And then the recover behavior, like if you want to tell an alien to recover, it sets its life points to whatever its recovery behavior says it should be. So the way that this gets used is I can create Fred and I can give him a recover percent behavior, and recover percent is going to recover 42% of the points that it has lost. And so I created him with 100 points and then I whacked him, so now he only has 50 points. When I tell him to recover, he should get back 42% of the 50 he's lost. And if you look at the output, Fred starts at 100 points and he has a magic recovery behavior that is a function pointer. It's a pointer to a piece of code. I hit him, he goes down to 50. I tell him to recover, he goes up to 71. And then I can create a different alien named Mighty Max who can recover all his points. Every time the clock ticks, he heals completely. And you can see that when I hit him, he goes down to 50, and then when I tell him to recover, he goes all the way back to 100. And the difference is I give him this recover all function when I create him. So this is feels like the strategy pattern to me, done with function pointers instead of objects, but that's okay. But the downside to this is all of these functions have to have the same signature. It's exactly like when you use function pointers in C. They have to have the same signature. So you'll notice that my percent recovery has a hard-coded number. Like I can't pass in one alien has a 10% recovery and another alien has a 30% recovery. They all, if you have a percent recovery, you all do 42%. And if I wanted to pass in an integer that was the percent that you recovered, I would have to pass that integer into recover all and recover none. And I would have to put it up here in the recovery behavior. And that's really yucky because then you're passing things in that aren't used by functions. And, that's kind of creepy. So this worked, but I was displeased by the fact that if you had behaviors that had different parameters, you have to make the parameter list be the union of all the necessary parameters. And that's kind of yucky. So I was looking at this code and thinking about things, and I think I suddenly thought for a minute like a Rust developer. What I noticed was these things are mutually exclusive. Either you recover all, or you recover a percent, or you recover none. You never need two of those. That's an enum. Things that are mutually exclusive are enums. So I was like, oh, this is an enum. And the cool thing about an enum is I can attach different data to each one of the different things. So I built this. I made an enum that is for the recovery behavior. None and all don't need any parameters, but the percent one needs what is its percent, and I made it be a real number. And then I made alien, the struct alien, have one of those enums in it. And when you create the alien, you pass in what enum it should use, and it remembers it. And then when you tell it to recover, it has a match expression, looking at that enum and doing the appropriate calculation for that particular enum. And so now my Fred and Mighty Max look like this, where when I create Fred, I just pass in the enum that I want and give it the value that it needs to have. And when I create Mighty Max, he gets recovery behavior all. And you can see that it works exactly the same way the function pointers one does. But this feels very much cleaner to me. I don't have to have all of those little functions. I don't have to have all of the things have the same parameter list. This is like really, really cool. So I really, really like this. Then I said to myself, this switch statement feels like, if this is where I'm coding what is the recovery behavior, then recovery behavior ought to have how do all of the calculations happen. So I said to myself, can an enum have an implementation attached to it? And it can. So I have here the same enum, and I implemented in that enum how to calculate the recovery. So now all of the ways that recovery gets calculated are all concisely right near each other. And the match is in there. And then when the alien wants to recover, all it has to do is call calculate recovery in that recovery behavior, passing in itself, because that's how it gets the life points and the initial life points that you need to make the calculations. And for me, what I see in this, first of all, I'm very excited that I came up with a solution that is not the solution that was forcing the object-oriented paradigm into this. So I'm like really proud of myself for that. And what I really like about this is it acknowledges that recovery behaviors are mutually exclusive. It allows each recovery behavior to have its own data. They don't have to have anything parallel between them. And everything about how things can possibly recover is in this part of the code. So if something has to change or we have to add a new option, it's all in one place. So I think this is a really slick solution, and I'm waiting for your comments to tell me how this is not the Rusti solution, because it feels like this is like way better than function pointers or attaching closures to a struct with all of that boxed dynamic complexity. Please let me know what you think.